Hello, this is John OT. In this tutorial, we will introduce the Ultra Recording Simulator software and take you on a quick tour of the user interface. Ultra Recording Simulator is general-purpose software for the design, modeling, and analysis of advanced next-generation ultra-high-density magnetic recording systems. It is a Microsoft Windows application and is ideal for scientists and engineers that are interested in a convenient design, analysis, and optimization software. It has a minuscule learning curve. It computes coupled multiphysics problems that include magnetic material interactions, magnetoresistance, and thermal effects. Every design in URS is always based on one of several possible simulation schemas listed here. Here is the URS startup screen. This window that is displayed here is called the New Design Assistant. It offers a rapid and convenient means for creating a new design by allowing you to specify upfront key configuration properties for your design. After the software completely loads, you will be able to fine-tune the design further. The New Design Assistant takes you through several design setup steps. We are currently at the introductory page. We click the Next button to move on to step 1. The configuration selection is globally the most important input of the New Design Assistant. It determines the overall makeup and desired geometric and material properties of your design. The schema for the new design is selected from the simulation type box. Let us leave these inputs unchanged. Thus, our configuration will be a classic perpendicular recording without a media underlayer. We will carry out a writing simulation, and our solver type will be the quasi-static solver. Clicking the Help button at any time displays detailed information about the current page of the New Design Assistant. We click the Next button to get to the next page. This is the media setup page. Let us leave the default input unchanged. Let us click Next a few more times, each time leaving the data inputs unchanged. Here at the final page, we click the Finish button to close the New Design Assistant and to complete the creation of our startup design. There. With that, we have completed the start phase of our new URS design. The new design is displayed in this window, the System View window. These components are the main and auxiliary poles of a single pole head. The red arrows represent the equivalent magnetization vectors produced by the magnetomotive force. This component is the storage media. The tiny blue arrows represent the magnetization vectors of the media. This other window here is the main URS control window. This is where we specify the properties of designs. Next, we will run a calculation or simulation on the displayed design. The writing simulation we specified will result in the calculation of the recording of a storage medium by a moving write head. We click the Run button right here at the top. The calculation starts. Let's let it run for a little while. Let us pause it by clicking the pause button. Notice how the pause button is relabeled to continue, so that clicking it again continues the calculation. The Run button, on the other hand, is relabeled to cancel job, so that clicking it terminates the calculation. A simulation produces and displays an evolving sequence of magnetic states and output curves of the design based on design specifications. These windows here are output curves specified for the design. Let us reposition and resize them for clarity. There. Let us click Continue to finish the calculation. I will jump ahead and resume the narration when the calculation finishes. And here we are at the completed calculation. The output curves are fully plotted and the system is in its final solution state. This is the write head MMF signal profile, and this is the average transverse or cross-track magnetization profile of the medium. Let us now take a closer look at the URS control window. This window consists of two main panes separated by this vertical panel, which can be moved to resize the panes. The left pane is the data category pane. It consists of a hierarchical node list representing different data input categories. Each node has an identifying icon associated with it. The right pane is the data input pane. As each node is clicked here, appropriate data input areas are displayed here. This first node is the root node. It provides, among other things, an input field for specifying a descriptive name for the design and a choice of solver types for calculations. The calculation we just carried out was a quasi-static calculation. Pressing this button here resets the design to its initial magnetization state. Under the simulation node, you choose a design schema from this box. Different simulation types require different system components. These will be demonstrated in a later tutorial. You preview specified head motion by clicking the Show Motion button under the simulation node. There we have it. Using the writer node, we select a write transducer and specify its properties in this input area. Similarly, we specify reader and thermal source properties under the reader and thermal source nodes. A thermal source allows adding heating effects in calculations. The media node has two subnodes, storage layer and underlayer nodes. Using these, you can specify the properties of various components of a media sample. Related component data are grouped under different tabs. Let us briefly activate the underlayer. Here, you can see it appear in the System View window. The underlayer can be a normal magnet or a magnetic shield. Let us deactivate it again. There. In the input area of the output curves node, curves for the checked entries will be generated during a calculation. The output choices the user can select depend on the simulation type. The lines and colors node provides a centralized location for specifying line thicknesses and colors of components of the system, and the arrows used to represent their vector characteristics. The Views node provides convenient means for displaying different views of the system, for zooming into them, and for interacting with them in other ways. We display separate components of the design using this box. Controls under the Recording and Playback node are used to record and playback simulations. We are referring here to the process of storing system solution states, usually for subsequent post-computational analysis. We are not referring to technical recording in magnetic data storage systems. We will look closely at the use of this feature in part 2 of this tutorial. The Help button allows you to learn how the various parts of the program work. Help information is context sensitive. Much of the program's main menus play their usual roles in standard Windows applications. A specialized menu item is the Tools menu, which provides access to external productivity tools, among other things. And with that, we come to the end of part 1 of the Ultra Recording Simulator tutorial. Here is a recap of what we have learned so far and a preview of what's to come in part 2. Thank you.